So thanks so much for having me, and thanks, Vince. So I'm really excited to be here today and to give this presentation to you. I initially planned this talk to be 17 things product managers need to know when making technical decisions, but I found that I kept rambling on, and I needed more direction. So I cut it down into 7 things, but hopefully these are the most important 7 things that you can take away from me. But to get into it a little bit, Vince introduced me a little bit. My name's Ken Mazaika. My background is mostly in software engineering, so I went to school for computer science at Northeastern University. Following that, I ended up having internships at a guitar effects pedal company where I was working on the firmware. I worked for Microsoft and a couple of startups. One of the startups I worked for ended up getting acquired by PayPal. So I've worked at companies large and small in the capacity of a software engineer. I've also contributed to open source software. I contributed to the Ruby on Rails framework and a few other things too. And at the end of that, I realized that I wanted to start my own company. So I quit my job, I became a startup founder, and in no time I was running workshops together with Marco, my co-founder, and we started teaching workshops at places like Harvard Business School, Babson, Carnegie Mellon, and kind of all over the place. We realized that we wanted to go a little bit more deeper and get a little bit more technical, so we started this online coding bootcamp called the Firehose Project. And like Vince said, we ended up getting acquired by Trilogy, which is a really great company that sort of takes it full circle because they're helping provide universities what they need to give innovative education in these technical topics. So I kind of have a wealth of experience, and I have a lot of different vantage points. I have a lot of experience from the software developer side. I have some experience as a co-founder of a company where I'm more in touch with some of the business requirements and things like that. And I also had the experience of having a 5-person company try to plug into a 900-person company, and in the process I saw some of the things that work really well for small companies don't for big ones, and vice versa. So a little background on me, so hopefully I can be helpful. I'm hoping that this talk can be a little bit of a discussion, so there's Q&A at the end. If you think that anything that I'm saying, there's maybe a different perspective that you'd like to share, maybe just make a note of it, and I'd love to talk more about it at the end. And hopefully there's a break after this, so if you want to continue the conversation, feel free to just grab me, and my email address is up there too. And I guess before we get into it, the last thing I can mention is I have all these slides. Happy to share this after the presentation's over, so don't be like copying the slides because I can just get that to you. But cool. So yeah, this is going to be about a 45-minute talk, and the other thing that I wanted to talk about is some of the assumptions that I have about the things that you guys already know. Are you guys mostly familiar with how developers will get software requirements from product managers using tickets and things like that? Cool. And are you guys familiar with like version control systems like Git, GitHub? Cool, okay. So I'm gonna reference some of these topics a little bit, and I just wanted to make sure that sort of I don't start referencing stuff that's a little bit confusing.
There were a couple of folks that might not have known about Git. Do you mind just giving like a 2 seconds rundown on what version control is?
Cool, yeah, of course. So version control is one of the most important things as a software developer. So if you think about what software actually is, it's a collection of code which is just like text that spans across multiple files. And what a version control system allows you to do is it allows you to keep track of different versions of this collection of multiple files at the same time. So you can almost think about it like Google Drive, how you can keep track of different versions of a Google Doc over time, except that works on a single document. A version control system is going to do the same thing where it keeps track of the different changes across versions of files, but it's going to span across a whole project with multiple files and things like that. And it makes it possible for 2 different people to be working on large projects that contain multiple files with each other and share the changes and things like that. So version control is the general term that's basically saying this is how these types of software changes are shared amongst developers, and Git is an actual implementation of it that is pretty commonly used, and that's the version that I'm like most familiar with. There's other versions like CVS, Subversion, things like that, but most of the time you're gonna see Git and GitHub. So quick little rundown about that, and I'm gonna talk about Git a little bit and go into a little bit more detail about how developers can use Git in ways that'll help you out as a product manager. But yeah, so this is the talk is about what I wish that the product managers who I worked with knew about making technical decisions, and I also have a couple of tips about working with people like me and developers. And like Vince said, we met at the class he was teaching, and I still remember sitting down in a classroom like this, and Vince asked the audience, what are your biggest concerns, fears, and things that make you nervous about working with software developers? And these are people that were my classmates that I was talking with and things like that, and they were raising their hand and saying really like terrifying things, like they're gonna be awful at communicating, they're terrible human beings, things like that. And I'm like, I'm sitting right next to you. Like I've been talking to you this whole time. Like I'm a human being too. So I just thought that was funny, and if nothing else, hopefully walking away from this talk, you realize that software developers are actually normal people too. So yeah. Cool, so getting into the actual talk, so enough about this. The first thing I wanted to talk about is the idea of thinking about why and understanding different people's vantage points when it comes to technical implementations and things like that. Vince does a great job talking about how the key to being a good product manager is deeply understanding the problems that you're solving. And those exist both on the customer side, where it's like you're trying to build a product for these people. It's also going to help you a lot on the development side. So if you understand what problems the developers are facing and why they need to do things, you're going to actually make a lot more progress. So I encourage you to take the time to really think about what are the problems the developers need and try to go a little bit deeper. And I'll talk about that in a little more example, or with more examples, but that's kind of the big takeaway overall. I think one of the things that is easy to forget is, as a product manager, you're going to be one of the only people with visibility into multiple different facets of the organization. And a lot of times the developers are going to have one opinion that's sort of in one bucket, but there's going to be different areas of the organization, each with opinions, problems, and things that you need to deal with. And you're the only person that actually can connect the dots and see the big picture for what it is. So there's the analogy of the blind people that are looking at the elephant, and they're all touching different parts of the elephant, and they're describing like a different thing. Somebody that's touching the husk is talking about like this marble statue, and somebody else is touching the tail and is talking about the ropes in this thing, but they're all describing the elephant. So basically, as a product manager, it's your job to sort of take in these things, ask questions like why, try to understand the problem from a deep level, especially when it comes to implementation, and then take that and sort of use that to understand the big picture and push things forward. So a couple of questions that you can do to do this is just asking basic questions like, why are we doing this? When does it need to be done by? Does it actually make sense to do this? And if you actually think about it, these are really basic questions, but it's really easy for these questions to be really hard to answer. So one of the experiences that I have, having worked at the Firehouse project and like working on different projects and things like that, we didn't always do this right. So one project we worked on was building a course for Node.js. So we were working to build a new course. And it ended up being like about a 6-month-long project. And one of the things that happened over the course of this project was everybody thought that this project was being done for a different reason. We're a small team, 5 people, but each person of this 5 people had a different objective for this project. So I was more excited about the technology, and I thought that teaching Node.js would help de-risk some of the situations if industry moved in different directions. We had a curriculum engineer who just enjoyed working on really exciting cutting-edge things, so he was really excited about that. And the CEO was excited about the upsell, the business side. Could we get more revenue in the short term? And this is an example of everybody having a different why and having that cause problems on the business side, because when it came to details, does it make sense to add this feature or that feature? It was really difficult to prioritize what actually made sense. And when it came to timelines, our CEO was looking to sell this course really soon, whereas somebody that was more excited about building the project and the technology wanted to build it a little bit slower and do things more the right way. So figuring out the why, understanding it, and then being able to communicate that outwardly is going to help you out a lot, especially when working with developers. So this is an example of something that I think is really easy to understand. But if we think about some other examples where developers might come to you and give you requirements, it's easy to be in the opposite camp where you might not understand it at all. So I put some random stuff that maybe a developer could potentially tell you about. So maybe a developer comes to you and says, in the next 3 months, we need to migrate our infrastructure to use Chef and Amazon Web Services for a robust deployment architecture, or any of these things. And if somebody comes to you and says these things, it's really easy to just say like, yeah, sure, let's do it. But if you don't understand the why, it might not actually make sense. So even if an engineer is throwing a lot of buzzwords and talking about a deeply technical topic, doesn't mean that you don't actually have the skills to understand the reasons why and the problems that are being solved by that. So I have a couple of strategies. So the first strategy is asking those questions, pretty basic questions. Why do we need to do this? What's the timeline? Understanding the problem at a deeper sense. One of the other things that you could look at is design patterns and design thinking, because design thinking allows you to apply certain frameworks to problems in general and take them in a different way. So this is from a website called designkit.org. And this is going to have a bunch of different design frameworks and ways to break apart problems. And this is one that's called the how might we question. And you can check out the website, because I'm not sure that this is the most powerful one, but I think that having some experience in design thinking is going to be helpful. And it's just a nice example of when you have these really abstract things that you might not understand, if you can figure out a way to word these in a way that's more like, how might we achieve the needs that we have in a timeline that's half as long as the 3 months that we talked about, you might end up getting some surprising answers. So just because you don't understand something right off the bat doesn't mean that you should just give up and just take the engineer's word for it. You want to make sure to be able to understand things at a deeper level. So one of the other things that I wanted to talk about was the idea of being humble and asking questions, right? Because the previous slide, I showed you some questions that could potentially be confusing for you if you don't necessarily know all the details of Chef or Puppet or Amazon Web Services or any of those things. But realistically, one of the things that's most important is that if you're humble and you ask questions to people, they're generally going to be pretty receptive to that, and they're going to help you make the right decisions. So the example that we have is Jenna was a product manager at our company, and she came from business school, and she didn't have a technical background, but she ended up working together with our technical team, and she would work really well directly with like one-on-one calls with our developers, asking questions, and she also was really good about not asking the same question again and again and again. So if you have a problem that you don't necessarily understand, that's absolutely fine. Make sure to ask the question, write the answer down, and don't keep going back to the same people with the same question. But she was really great at that, and in no time she was building tickets like this one. And if you read it, you'll see that this is a fairly technical ticket. It's talking about Google Analytics, which when she came in, she wasn't an expert at Google Analytics, so she had to work directly with the marketing person to understand, what does the event tracking in Google Analytics do? Why are we tracking this? How is this all working? To get a deeper understanding of the marketing side. And then she was able to talk to the developer and find out, oh, there's problems with our front-end framework, the React.js that we're using, and was able to synthesize all of this stuff, not because she knew it all going into it, but because she was receptive and she asked questions. So this is just a great example of if you just go in and you ask questions and you try to be open to feedback, you can actually learn a lot. And I think it's really important, but at the same time, it's something that a lot of people don't necessarily do. So one of the next topics that I can talk about is the idea of technical risks and unknowns, because it's something that I think product managers and developers both don't really like. And it's because it makes things like estimating and planning really difficult. So maybe to get into it, I can explain like what are these things, what are technical risks, and what are unknowns. So technical risks are the risk that what's being asked of you is actually impossible or nearly impossible to do. So one of these examples could potentially be something like if a product manager came up to a developer and asked them to retroactively charge customers credit cards for a certain fee amount that maybe was missed on the initial transaction. This could be something that's really easy, But if the credit card wasn't stored in some system, or if the API that's collecting the payments, if there's situations going on there, this might actually be something that's physically impossible because the credit card might have come through the system and then sort of left the system and have no way to do it. So this is something that could be really easy, it could be impossible, and it's really difficult to know. Another example of this is the unknowns. So those are things that are probably possible, but people don't necessarily know how to do it at all. So an example of this we had at the Firehose project when we were trying to integrate with Fresh Sales, which is a CRM system, with our landing page, which is Squarespace. So we were pretty sure that it would be possible to somehow make it so when somebody entered a lead form here, it would end up in the CRM system. But going into it, when the marketing person asked me to do this, I didn't necessarily know how I was going to do this. I wasn't an expert at the CRM system, so I was like, I can probably do it for you, but I don't know if it makes sense. So it took some time, and I ended up doing some research on the Fresh Sales API, and it turns out that the Fresh Sales API was actually really easy. So we worked together, we talked about it, we implemented the feature, and we took it from there. But going into it, when we started the conversation, we didn't know if this was going to be an easy task or a really difficult task, and that can make things like planning really hard. So that's where technical spikes come in. So I mentioned at the beginning that one of the things that's important to know is like the idea that tickets are being used to give work to developers. When you have a small team of 5 people and there's like 1 or 2 developers, it's pretty easy to just work directly with the developer and figure out what you need to do. But on larger teams, this kind of doesn't scale that well. So the idea of a technical spike is the idea of having something where the outcome of the work is not in shipped code that goes live on production. Instead, the goal of a technical spike is learning about things, de-risking it, and making it so the knowledge is actually easier for scoping and planning and things like that. So basically what you can do is you can just make a regular ticket, add the word spike at the top, and then just walk through what the takeaway is. The takeaway of this ticket is to deeply understand, in this case, maybe the Fresh Sales API, understand how we could integrate this and understand how the lead form works and how we could potentially plug it into it. So you could make a ticket for that, and the developer could give you an estimate for how long it'll take to generally figure things out without necessarily shipping the feature. So in this case, understanding, getting like a rough plan for how to do this would probably take a day or 2, something like that. So in this case, the technical spike doesn't include all the details of actually implementing it, but just understanding enough to be able to fill in the gaps. And it can really help accelerate the planning process if you have this. Another thing that's worth mentioning is that when working on experimental features and things that may or may not go live to production, one of the things that developers can use is the idea of GitHub branches. So GitHub branches are a fairly advanced feature of GitHub that allows developers to start working on things, but then make something like a copy of that, where they can continue to work on that later and incorporate it into the main one if they want. But if they choose not to, they can just act like that copy never happened. So it's a great opportunity if the code ends up being successful. But if the code isn't worth implementing because maybe this takes far longer than it makes sense to, it can easily be reverted and act like it didn't happen. So a couple of tools in your tool belt that you can use when talking with developers, especially if there's tickets that have a lot of risks where maybe it is possible, maybe it's not, or unknowns where developers are like, I don't know how to do that. So those 2 are technical spikes and GitHub branches. So the next topic I wanted to cover quickly is the idea of the level of communication that you want to have with specifically developers, and a little bit less specifically, it's individual contributors in general. So individual contributors are people who generally add value on a project by doing most of the work. So a software engineer generally adds most of their value by producing lines of code that produce shipped features and things like that. So typical engineers, you generally will want to talk in very concrete terms. So instead of using generalizations or abstract wording, you want to be very detail-oriented. So if you were to potentially go to maybe like the CEO of your company and start talking about your web application and the feature that you're building, you probably wouldn't be talking about details like the color of a button or how to position something. These are really concrete things. These are really specific things. Conversely, if you're talking to an engineer, if you're thinking about revenue projections or things that are more big picture and up in the clouds, that's not going to necessarily matter to the engineers. So when you're talking with engineers, you're generally going to want to be focused and have very specific things and talking in super concrete terms. And as you talk to more and more senior developers, you can end up being in a situation where you can use more and more abstract and general topics to communicate what you need to. So that's the conceptual part of this, but now if we want to talk about a little bit more of a detail that you might actually face in the real world, there's some of these things that maybe a CTO could come to you and tell you. And they could tell you things like, this needs to scale really well, or this feature is going to have a ton of usage. In some ways, this says a lot because it says, hey, we have to make sure this is going to work. But in other ways, this actually doesn't say anything, right? So this is something that's both abstract because it could mean a lot of things, or it's both vague because it could mean a lot of things, but it's also abstract because it's taken away from what's actually happening, and it's thinking about something at a conceptual level. So when you face things like that, another takeaway is continuing to ask questions. Ask questions to understand why, understand how, and things like that. So how does it need to scale? Why does it need to scale? And when does it need to scale by? And figure out how to take abstract terms, vague terms, and distill them down into very specific things that are tangible that developers can actually work with. So if you get those requirements and an engineer or like the CTO tells you something like that, it doesn't mean that you can't do anything about it. One of the things that I would suggest is coming up with projections. So here's a projection of concurrent users. So if somebody comes to you and says something needs to scale really well, you could ask well, how does it need to scale? Why does it need to scale? And maybe you'll find out that there's just going to be a bunch of users on the site. Well, okay, what does that mean? So you can say month over month, maybe it increases by a large factor, and then you could find out, well, why is it increasing? Well, some of it might be organic growth that's sort of happening because the company is growing, and some could be because of changes that are happening. Maybe new partnerships are launching, or the feature is widespread available, or something like that. So basically, once you get down to that point, you can come up with some rough projections, which maybe these are completely wrong, but at least it causes people to start talking in concrete terms. And this is going to give a developer a much more focused sense of what they need to accomplish, as opposed to just these vague things over here. So when you get requirements that are vague, work to refine them, get them really specific. And even if they're wrong, if you shared this with the CTO, he could tell you that it was off by a factor of 2x, or maybe the partnership isn't going to happen until this month. Even if it's wrong, you can start talking about the details and focusing on the concrete terms instead of just being up in the clouds and talking generically. So one of the next topics that I wanted to talk about, and I think this is one of the more important ones, is the topic about alignment, momentum, and trust. Because that's one of the things that, working for a 5-person company, you kind of get a lot of that for free. But as you work with a bigger and bigger company, these factors end up becoming a bigger and bigger deal. But basically the gist is, if you have a team that's really aligned on getting the same thing done, they have momentum of shipping and making progress day over day, and that everybody believes that we're working for the same goal, people are able to do pretty remarkable things, and you're also able to break kind of a lot of rules. So when we had this 5-person company, we did a lot of things wrong, and this is an example of a real ticket that we ended up shipping. Then I wrote this ticket, and this is not really well written, right? This is just a couple of sentences that say, hey, just remove this. And it doesn't mean that necessarily you should go around writing terrible tickets like I do, but it does mean that you can take some time and sort of think about how much trust do you have with the developer that you're working with? How specific do you need to do it? Or are there other ways that sort of the details can get fleshed out? So in this case, I made this ticket, and the developer came back to me, and we were talking in Slack, and we had a couple of video chats and things like that. It doesn't really scale if you have 10 developers, But if you have one developer, it actually can work pretty well to actually just deal with the issue in real time. So process is something that can be used to create alignment, create momentum, create trust, and it oftentimes will give you transparency. One of the other aspects of process that you're going to want to think about is like the meeting cadence that's going to happen with developers. So typically on development teams, there's standard meetings that happen week over week. So things like stand-up, sprint planning, things like that. And these are all designed around manufacturing trust, momentum, and making sure everybody on the team is aligned. And a lot of them are really great ideas, but for a development team of like the size of one, maybe a retrospective isn't the best use of everybody's time to sit down for an hour a week and talk about what we learned when you're constantly in communication with this person anyway. So it's like, there's not going to be a whole lot of value there. So basically the gist is if you're in a situation where you can feel that sort of the team is all moving in different directions and this person over here is working towards one goal and this person's working towards another goal, or maybe it's even just unclear, maybe there is no momentum. So it's like, we need some more transparency on what you're working on because I don't see what's actually happening. So all of these processes are used to generate the momentum, the trust, and the progress that can keep things moving forward. But rule of thumb is, as developers, as a developer myself, I've always wanted to spend most of my time doing the craft that I was hired to do. So I want to spend time coding. I don't want to spend time in meetings talking about stuff that, especially if they're not a useful use of my time. So basically use process as sparingly as possible. And if you work for a very small company, like 5 or 10, you're probably going to have a pretty big say in like what type of a process needs to happen. If you work for a bigger company and the dev team is 20 people, 30 people, something like that, the dev team is probably already sort of trucking along and sort of doing what it needs to. But basically, as you scale and as more people come on the team, process is something that you're going to need to use in order to keep things moving forward in the way that it was when the team was smaller. So the next topic is highly related to that, and this is probably one of my favorite topics, especially as a developer, and it's the idea of the Mythical Man Month. So this is a fun one because it's the idea that software projects and projects in general are not like manufacturing jobs where you can just put more people at a problem to make it be solved faster. So the concrete example of like what a Mythical Man Month is it's the idea of, if this feature will take one developer a month to make, let's just put 4 developers on it and get this done in a week. And managers, and sometimes like conceptually that kind of makes sense, but when you actually drill down into the details, that actually doesn't work at all. And there's certain upper bounds in terms of adding people, and there's also problems, especially when it comes to the previous slide. Things like alignment issues happen when you just put people together. Trust issues happen if people don't have experience working together, and if there's no history and shared experience of like building features together, momentum slows to a halt. So you can't just throw people indefinitely at a problem and expect it to get better. And that's kind of what the Mythical Man Month is saying. So more or less, make sure that the team that you're building is being built in a very deliberate fashion, as opposed to just ad hoc trying to throw people at problems when they're moving too slowly. Understand actually what are the problems that are happening? Why is the dev team moving really slowly? Putting more people on the dev team might make it faster if you're kind of stuck at the capacity and that one developer is working really hard, but it also can be the situation where throwing more people at the problem isn't necessarily going to solve it. So if you want to learn more about it, there's this book called The Mythical Man Month, and that goes into a lot more detail about this topic. But it's something that I think all product managers should have at least some familiarity with. And the last topic that I was really excited to share with you is the idea that it's important to know when to let something slip through the cracks. So as a product manager, it isn't necessarily your job to make sure people are doing exactly what you tell them to, but rather to make sure that the product is being built in the best way possible. So in this example, you can see what we got back from our designer, and it's actually kind of cut off on this one. But if you look at this one, you can see some of the designs that we got back from our designer, and you can see what the developers actually ended up shipping. So if you scroll down and you look at the middle section, you can see that the logos are a little bit different, right? The logos are kind of like stretched out and scaled in the one that was actually shipped. And you can also see that some of the spacing is a little bit messed up, right? There's a little bit more spacing in the one that the developers shipped, where the designs that we got back from the designer had everything really nice and narrow and things like that. So this is an example of something that you might end up getting back from a developer, where it's pretty close to what you asked for, but maybe it's not exactly what you asked for. In situations like this, I think it's really important to ask yourself, is this something that actually matters? And is this something that needs to be fixed? And if this was a landing page that was going to go on TechCrunch the next day or something, it probably does matter quite a bit. But if this is just like a landing page that's like somewhere buried in your site that doesn't exist now, this could be a situation where shipping what you have is better than just waiting until it gets perfect. So I guess don't let the perfect be the enemy of the good, and ship when it makes sense to ship. And I guess the last thing that I wanted to say is you're probably going to learn a lot about specific strategies and specific plans about like, hey, when you're working with a developer, do X, do Y. I would really encourage you not to take these concepts and just map them one-to-one with the situation, but instead zoom out and try to ask yourself, like, what problem are you actually solving? If you're pattern matching and trying to formulaically solve problems without actually understanding them, it's really possible to be in a situation where you're solving problems that you don't actually have. And one of the examples that I have from my experience was when we had a dev team of one person, we didn't need to have these regular meetings that are called poker planning meetings. And in poker planning meetings, if you're not familiar, basically developers take these tickets where it's defined work, and they say, this is about how hard it's going to be. And there's different ways to go about it, but the idea is this going to take you an hour? Is it going to take you a half a day? Is it going to take you a full day? Is it going to take you a whole week? And that can be used to sort of define like the scope and the level of effort for a ticket. When we had a team of one, we didn't really need these meetings, but as we scaled up, we had more and more people on the team. These meetings became more and more helpful to make sure, like, are these tickets that the developer is working on scoped out well enough for developers to do? If they're being asked to like add a button to the page, but they're saying it's going to take a week, something's probably off, and maybe that is the fact that it's not defined what the button's supposed to do, or something like that. So basically, when you have a small team, these things are less important, but as we grew, that became a bigger issue. But then we ended up getting more and more developers, and they didn't necessarily have the experience that they needed with our actual product to understand how to define if something was going to be something that's easy or something that's hard. So the process is something that actually makes a lot of sense in theory, where you should have these poker planning meetings and do things the right way. But in our situation, it didn't work because the developers on the team were new to the project. And at that point, there was probably 6 new developers and 2 experienced developers. And in a situation like that, that's not a typical situation that these agile practices are being defined to handle. So I guess the rule of thumb is to avoid just doing things that you're told sort of because you're told to do them, and think more deliberately about, is this actually going to help? And don't just say, hey, this is considered best practice. People tell me to do this, so you decide to do it anyway. I wanted to list out a couple of topics that I think it's helpful for product managers to know about. So I don't think that product managers need to be the most technical people in the world, but there's a few topics that will give you disproportionate value if you end up getting a little bit of experience in them. And this isn't really like a technical talk, so I'm not talking about all these details, but it can be really helpful if you want to take like a Udemy course on something like this, or just dig a little bit deeper so when you're talking with developers, you're able to communicate in the same way. So Git and GitHub came up a couple of times in this talk, and it's because it's really important for developers. So because it's one of the tools that's going to be in a lot of their tool belt, having a little bit of experience with that is really helpful. And because branches are how developers are going to be able to quickly change and jump between versions of their work, it's a feature that you should definitely, if you're learning about GitHub, you should definitely focus on that. I listed out monoliths versus microservices. I think it's really possible when you're in situations talking with the developer team to talk about potentially building new projects out and using new architectures and new ways and things like that. Understanding both the old way that's pretty common and the new standard can be really helpful, knowing the pros and the cons, and is this actually worth the time to do it? And there's a lot of pros about sort of, or a lot of benefits about using microservices, which is kind of the new standard to do things. But there's a lot of value that you get from using a monolith too, and there's talks online that you can watch where people tell you the pros of using it the old way. So everything is sort of shades of gray. The last three things, I guess, are these three-letter acronyms that are probably worth at least having a little bit of experience with. One is APIs. So in short, APIs allow two different systems to talk to each other. And you wouldn't need to be an expert in all APIs, but if you have a little bit of experience integrating with like one API or something, you can talk in more concrete terms to developers when it comes to the problems that they're facing and things like that. So if you found like a quick tutorial about how to build with one API or something, it could be helpful. And understanding test-driven development is something else that could be helpful too. And the idea of test-driven development is the idea that if you have a good test suite, it will speed up your development process quite a bit because you can have automated software tests catching bugs and preventing regressions. So it slows you down a little bit in the short term, but it ends up speeding things up in the long term. So I wouldn't suggest becoming like an expert in TDD, but maybe read a blog post or something about it, understand the concepts. And the last thing that comes in really handy is, I'm sure like probably half of you guys, maybe even more, already are familiar with SQL, but SQL is the database querying language, and being able to pull data yourself from databases instead of having to email back and forth with developers can speed things up quite a bit. And SQL isn't terribly difficult, so you can take like a Udemy course or something like that and get up to speed on SQL pretty easily. So all this stuff is all completely optional, but if you do want to sort of do a deep dive into some of the technical topics and really be able to communicate with developers in really on their level, that can be really helpful. The one word of caution is as you become more and more technical, make sure you don't communicate requirements to developers with implementation details, because it's something that's really easy to sort of fall into that trap, and I do it all the time, especially because of my technical background, where I will specifically add in words that end up throwing the developer completely off track. So an example could be to make like a GitHub ticket that says something like, center this button using Flexbox to do X, Y, and Z. And maybe there's a different way outside of Flexbox that you can center this, but it might take the developer like twice as long to do it. So basically, treat these things as a double-edged sword. It can be helpful. It can speed you up a little bit if you have cursory knowledge of it. But at the same time, if you go back to the first slide, if you ask questions, if you're humble, if you're open, developers will work with you to teach you what you need to know. I have some links that you can see after about blog posts, books, stuff like that, that if you're interested, can all be helpful. And that's pretty much all I have. So yeah, like I said, my name's Ken Mazaika. That's my contact information, so feel free to shoot me an email if you have any questions. And if anybody has any questions now, I'm happy to answer them. And besides that, I think after the talk, we can also talk more one-on-one. So I'll be around for a little bit if people have specific private questions. But for more general questions, does anybody have anything they want to talk about? Sure. Of course. So the concept of a technical spike is the concept of a user story where the takeaway is not necessarily the feature that's built, but instead it's going to be the learning that happens after the fact. So when working with like a new framework, a new tool, a new technology as developers, when we're working with something that we don't have a lot of experience with, it's really common to just be like really fuzzy, and it's being asked to do something that is completely outside of your wheelhouse. So you can basically make a ticket that basically is just giving a developer permission to kind of like go off in their own world, do a little bit of research, come back when you get the answers to these questions. And they don't have to be super vague, but if you generally talk to a developer and be like, hey, what's the timeline for integrating with the Fresh Sales API? They're gonna come back and they'll be like, I don't know. And it's like, how long will it take for you to get that answer? They're like, I don't know, maybe it'll take me 4 hours. Then in that sprint, you can put in a ticket that just says technical spike, learn about Fresh Sales API. Then all of a sudden, because it's in the backlog, it's in the ticketing system with all the other tickets, that can get sort of put to the top of the list. And instead of the developer being in a situation where they're forced to just work on feature that's getting shipped after a feature that's being shipped, they can sort of take a step back and be like, okay, now I'm doing work that's sort of like approved of. The product manager says I can work on this, but at the same time, I'm not building the features that's sort of in this thing here. So it kind of is using the product backlog in a way that's a little bit outside of the typical way, which is like ship this feature, ship that feature. Cool.
So then are you using that as a way to like manage burnout among your developers? Like if they're just churning through projects, you're like, here, go learn about this instead of, or is it just purely?
I think that's a fascinating question. So the question is around managing burnout, which I feel like could be an entire talk about that. And I feel like if I would not be qualified to do that, I feel like I'm qualified to tell you how to burn out. But yeah, so I think technical spikes are things that sort of are usually going to be tied more directly towards this is something we need for this project, and it's going to be used more laser focused in the sense of we need to do this to ship this out. In order to manage developer burnout, there's a few different strategies that you can that people use. One of the strategies that we used at Trilogy was, I think they called it deal, drop everything and learn. So there was a certain amount of time that was sort of blocked off on people's calendar where it's like, this is time that you can just you cancel any meetings in this time and just learn about anything that you want to. So it's kind of a cool opportunity. We had a partnership with like Udemy, and developers would take courses like that. So that's one of the things. I think when it comes to actual tangible things about managing developer burnout, it's not so much what you can do on top, so much as what you don't do on the other side. So setting realistic expectations for developers is going to be a lot more effective than telling them that they have like a block of time to do something. Because if they spend the 2 hours learning something fun like Go or something, but then they end up having to work the weekends, like they're going to get burned out anyway. So it's like you can't just add stuff on top. So I think to manage developer burnout, setting realistic expectations, and there was going to be a slide in this before, but it's the I called it the conveyor belt of like milestones or something, and it's the idea that whatever you're working on next in everybody's mind is going to be the absolute most important. Drop everything and do this. But as soon as you accomplish that, something else is going to replace it. So basically, it's easy to sort of get in this like startup grind mentality where you're just like, everybody focus over here, focus all your effort, and then you're just like burn it all out. You step on the gas and you just like burn all the gas out, and then you ship that, and then it's like, oh, well, now we have all these users that are giving us all these feedback now that the MVP is launched. So basically, it's just the best way to manage developer burnout is just setting realistic expectations and being like experienced enough to be like, this might be the most important thing today, but the biggest long-term value is the fact that the team was working together, has trust, and is cohesive. So encouraging people to like play ping pong and do things that are maybe not actually valuable for shipping the project. But this is something that I think every team is working with, and I think it's easy to do this wrong for sure. Yeah.
I had a question when you said sometimes done is better than perfect, or ship better than perfect. How do you balance that out with this over time?
So can you, there's two different ways that your question could be interpreted. So I'm curious if you're talking more on the technical side from like the developer shortcut standpoint, like they're building it too fast and making trade-offs, or you're talking from like sort of the pixels are sort of off and then you end up with this whole sort of kludgy system where everything's just a little bit strange.
I guess more from maybe a process
It's a really good question. And I think every team and every product manager is going to deal with it a little bit differently. How we did it is we would generally not address most of the things that we thought we were going to. So we called it V2ing something, and we would just say like, let's do this in V2. And then like that landing page that you saw ended up getting shipped. And the piece of that story that I didn't tell you is nobody actually ended up buying that product because of marketing reasons. So nobody was being sent to that page, in which case this is a page that sort of we could have worked on all of these things, but now that we have the experience, it's like, well, let's send a couple of people to this page before we start optimizing it with. So that's one concrete example of like, we probably will never go back and address that until we sort of say like, hey, the next initiative is to get new users on this course that we just launched and really like double down on this course. So I guess, my suggestion is to V2 as early as possible, keep it on the back burner and keep thinking about it. And if you end up sort of seeing that sort of the shortcut that you took actually is causing problems for either your user, like conversion rates, whatever the actual goal is, then go back and revisit it. But you almost, it basically needs to go through the whole cycle again at that point, where it's like, it no longer is sort of in sort of the development stage. At that point, you sort of take it back out and you go all the way back through sort of the learning about it. And for all you know, you'll end up sort of starting with, we need to do changes on this marketing landing page, and then you'll be sort of in left field where it's like, actually, the problem the customer has is that instead of React, they want to learn Angular, and then you end up building a new course or something instead. So I think it's not a great definitive answer, but then the flip side is there are situations where there's important things in your product that, and this is, I come from more of a development background, but I think there are situations where your product has certain defining qualities that you want it to have that maybe aren't necessarily definable, actionable by metrics and things like that, but you maybe want your homepage to have this premium feel so you can close like a big partner that's going to be like a $2 million deal or something. Well, in that case, you might not actually be able to go through the whole cycle to do that. So everything is going to be a case-by-case basis, but I guess at the end of the day, use your best judgment. And a lot of times, if you take a step back and you actually ship the V2, you end up getting a whole new perspective on it as soon as it hits the world, and you're able to tackle the same problem in a vastly different way. Totally. Hopefully, it changes it in a good way, but maybe I can zoom out and talk about it a little bit. So test-driven development, to just recap sort of the previous thing, is the idea that software developers themselves will end up writing the software tests that can be used to make sure that the software that's being written isn't bugged or there aren't any problems with it. And one of the main benefits to test-driven development as a developer is to prevent you from making mistakes as you're shipping the code that you didn't know about. So it's actually really easy to like go into a code base trying to add a feature and then breaking something completely unrelated because you just don't know about it. So test-driven development allows you to write software that will just run against your project and make sure the new feature that you added basically works the way that you expect it to. And the nice thing is that you use the same test later down the line when somebody else is working on a different feature or something like that. So it builds up sort of this foundation that ends up being helpful. So that's kind of like a little bit of background on test-driven development. So realistically, the change that it has to the process is it means that to ship a feature, it takes a little bit longer. So it's going to take the developer time because they're going to have to write the software test. Test-driven development means they actually write the software test before they ship the feature. That's kind of like the best world scenario. A lot of times they'll write the feature, then write the test, and they'll merge it together at the same time. And that's kind of TDD-ish too. In those situations, it's going to help the developer catch bugs while they're building new features and build the new features faster. So that's going to be helpful to them. But realistically, most teams, if you already have a QA department that's testing stuff, you'll generally continue to push new features to the QA team to test. So it doesn't really change their responsibility at all because you're adding a new feature and it's still on them to give it the green light. Hey, this feature actually works. And they are ultimately responsible for it, but hopefully using test-driven development, it allows developers to catch problems in their app before they sort of completely commit down a different path. And they also have less back and forth with these QA people. But generally, if you're going to have a QA person, even if you're doing test-driven development, you'll continue to have one. Or sometimes you'll be a small team of like 5 people, and it's like you have to QA your own stuff. So it doesn't, it's helpful, but it doesn't really fundamentally change the organization on the team.
I just wanted to understand, so we spoke about the software developers, right? So have you had any experience working with like product architectures or system architectures? Because the software developers who would be actually technical architecture, but when you're defining the architecture, you might not have all the requirements hashed out. So is there any specific process you have used in the past when you're defining system architecture?
Do you have any like I'm curious if this is a question that's sort of more generic, or if there's like any experiences that you've had personally that sort of like I could talk more directly to the experience.
So, I mean, so I work for a technical consulting firm. So the experiences I have had are more or less like I have a team of big data architects, and then I have to interface with them to kind of figure out if, based on the client requirements, architecture makes sense. And then when start actually, and at that time you don't have all the user stories hashed out. So a lot of times what happens is that when the user stories start getting hashed out, your architecture is more or less halfway through finalized with the clients, but then you realize, oh, maybe we shouldn't have used S3, or maybe there was another API that we should have considered. So those kind of things, like have you used any process to kind of, because a lot of times what happens is it comes from the end developer, like software developer, that this is the user story I got and this is the architecture that was proposed, but this is not going to work.
Yeah. I think it's a really fascinating question. So to just to recap the question real quick, the question's about software architecture and basically what to do in situations where the software architecture, which is kind of like the big level sort of view, the zoomed out view of what the software all looks like, kind of conflicts with some of the actual details. So basically like you're telling me that I need to build like a house that's like a brickstone, that's sort of the house, and then you find out that you need to have like a river going through the middle of it. And it's like, well, like, do you want the river or do you want the house? Because like you can have one or the other, like you can't have both. And that's something that can happen. But I think that one of the things that's gonna be really helpful is, and this is something that I'm like a strong proponent of, and it kind of permeates through like all levels. So this is talking to technical people, but any time that you're dealing with something where there's sort of like a big level conceptual abstract problem, and then you also have like a lot of implementation details, and there's different people involved at both steps, the person who's actually doing the work is oftentimes disconnected with the person who's like in theory land. So what we found worked at Trilogy with that was the idea of starting a scrum of scrums, which basically was pulling in the people that were actually doing all of the work and having like just a quick stand-up, like one lead engineer that's actually doing a lot of the implementation, and have them communicate some of the actual details to the same group that sort of the architecture person is. So basically getting these two viewpoints to come together. So basically, I guess the answer is basically to like bridge the gap as much as you can. And in a company that has 5 people, it's like I'm the person that's like speccing the architecture and building all the stories, so I can kind of like do what I want to do. But with larger companies, basically if there's a gap between these 2 different people, you have to figure out a way to bring them together and make it so these 2 people are talking to each other. So when an issue comes up with the architecture, the developer that isn't doing the architecture, that's actually building all the features, feels comfortable to go back to the other person and say, hey, this isn't really going to work in our situation. And it will help in the individual project where it's like, hey, it might help some in the individual project, the first one that you do this, but if you end up building the relationships between these people, hopefully, ideally, the person who's thinking more conceptually about the architecture will start to consult the person that's actually doing a lot of the work and be like, hey, I'm thinking about this for the architecture. What do you think? And that person's opinion, even though they're thinking at more of an individual level, it's really important when you're thinking high level conceptually. So I guess long rambly answer that says basically bring these two different people as close together as possible and build the relationships.
Just to follow up, so I mean that is quite possible if you have the requirements hashed out when you're defining the architecture. But a lot of times when your end user or clients who have given you the requirement don't know what they want in the end, they just know half of what they're expecting, and that half caters to that. Have you ever faced this kind of thing? The requirement, half of the requirement comes later, and then your architecture is basically not scaling to that requirement.
Yeah.
So for example, they say that 1,000 people will use this, but they don't say that 100 users will be concurrent using it or something.
Yeah, I think there's an interesting blog post that you can check out, and I think that it kind of, to different degrees, it applies to all software projects. There's this concept of a duct tape programmer, and that's the idea that sort of you're building a go-kart and you're driving it at the same time. So basically, like, eventually, like, a lot of the decisions that you make might end up being poor decisions because you're kind of like duct taping on stuff here and there. But in situations like that, you just have to do the best that you can and just basically work with the developers as you see fit. There's not sort of like a, I'd love to tell you sort of like a magic trick to fix that problem, but I think if you get that answer, I think you're onto something big. Any other questions? Yeah.
You showed that example of product manager who did not have technical background.
Mm-hmm.
In such cases, when you're working with the developers, apart from trusting them, what are other ways to verify that they're getting it? How do you develop that network that for non-technical?
So specifically, the question is around estimates and basically understanding when an estimate is correct or incorrect or something like that.
Yeah, how does a non-technical product manager build that practice? Is it more through experience or how does somebody do it?
Yeah, I think it's a great question. So basically, how can you sort of do a good job as a product manager to like scope out the level of effort that a development task will take? And I think that when you're new, it's going to be really hard, and you're not going to be able to. But if you keep your eye open and try to like notice patterns and things like that, like one of the things that would often come up, which actually was involved in a lot of projects that I wasn't involved in, but like at Trilogy, the company that I came from, whenever a project would involve Salesforce, all of a sudden like the complexity would go through the roof because like the API is really confusing and things like that. So like probably going into that, I'd be like, add it to the CRM. This can't be too hard. But then after like that happens like 4 times, why is this taking so long? Oh, Salesforce always takes a long time. Okay, well now pad out that example. So I think when you go into it, sort of keep an open mind. Trust the developers, let them kind of make mistakes. I think when developers end up sort of missing their estimates by small factors, it's like, okay, that's not that big of a deal. When they end up missing it by longer factors, though, I think that's one of the things that's kind of interesting. You said this was going to take a week. It's been a month. Now you're saying it's going to take 2 more weeks? Like, what's happening there? And there's a whole idea of sunk costs and things like that, which was a slide that I was going to include, but I didn't actually get to it. But yeah, I think that realistically, when you're new, just you got to go in believing them. Ask questions to understand when things are missed and try to understand that and use your gut. And if it's like, hey, make this button blue, and they say this is going to take 3 days, it's like, this doesn't make a whole lot of sense to me. Explain it to me. And it's like, well, you're asking for a blue that this monitor doesn't support or something. It's like, okay, maybe then, but like, who knows? So I guess it goes back to everything. Ask questions, try to understand the best that you can, and trust the developers as much as you can until you can't. And then you kind of have different problems on your hand. Yeah.
I guess continuation of that, you mentioned that poker meeting. How does that work?
Cool. Yeah, poker planning is interesting. It's something that I actually didn't have a whole lot of experience with until we started using it at Trilogy, and it was actually like very effective up until it actually had some major problems because of the way we scaled the team. But the concept of it is the idea of you have this whole backlog of these tickets that you've sort of said, which are the specifications of all the work that developers need to do. Each of these tickets ends up getting dragged into like a concrete unit of work called a sprint. And basically before that sprint starts, so this section of work gets kicked off, you basically have all of the developers come into a single meeting. So usually it'll be between like 4 and 8 developers, product manager, and maybe a project manager if you have one. And they kind of all get together and they kind of go through the stories one by one. And they basically say, how long do you think this ticket will take to build? So it just asks everybody. So there's different ways to go about it. It's called poker planning because traditionally it's done with a deck of playing cards, and everybody has like an ace, a 2, a 3, something like that. So a ticket is presented. It's, okay, we're going to add this landing page for the React course. How long do we think that's going to take? And all the developers like kind of grab their card. Everybody ready to go? Everybody's ready, thumbs up. Everybody flips over the card. And then you kind of talk through the stuff. So if you end up with like 3 aces and 1 like 2, it's like, hey, what's going on here? Like, why is this so low for you? And they're like, we already have this one. And it's like, oh, these other developers didn't know that this was already built. So that kind of changes sort of the, or maybe it's like, hey, this sounds really easy, but this is using the Salesforce API, so this is actually going to be really hard, or something like that. So basically, it uncovers these kind of like missing sort of like sections, but generally it's done tactically through either in physical rooms, through a deck of cards, and it's not actually a deck of playing cards. There's special ones called like planning poker cards that you can buy online, and there's also websites. I think we use like pokerplanning.net or something, and everybody has the site open, and you just press the button, and once everybody votes, it flips over the cards, and you can sort of talk about it. And there's some interesting, last thing I'll sort of mention is when it comes to sort of the level of complexity of a ticket, there's a lot of different ways that people can sort of specify this is easy versus hard. And a lot of times developers are going to be really opinionated about like the way to do it. It's generally pretty unimportant so long as everybody's playing by the same game. So if somebody wants to do it in days and somebody else wants to do it in like level of complexity this way, like you can like find research like blogs about different ways to do it. The actual implementation is pretty unimportant, but the important thing is that everybody in the room is just like on board for that. Cool. Cool, thanks so much.